In today's episode, I'm going to be testing globally distributed database latencies between CockroachDB and Azure Cosmos DB. To recap, I've tested CockroachDB, AWS Aurora, and GCP Cloud Spanner, where in CockroachDB I was seeing read and write latencies of around 5 and 7 milliseconds when my application was in Virginia and my database was in Virginia, 15 milliseconds read and 20 milliseconds write when my application was in London and my database was in Ireland. And in Aurora, when I was talking to the primary region, so the write node, I was seeing 3 milliseconds London to London, 10 milliseconds write London to London, but 400 milliseconds read latency when my application was based in Virginia, but I was doing async replication from London, and 110 milliseconds write latency when my application in Virginia was writing to the only write node in London. I then tested Cloud Spanner. I was seeing read latencies of around 40 milliseconds when my application was in Virginia, but I was talking to the database in Iowa and Oklahoma, and this was with the North America, Europe, Asia 1 multi-continent setup, and I was seeing 130 milliseconds write latency. I was seeing 130 milliseconds read latency when my user wasn't close to the primary spanner region, so that was a London-based application talking to the read-write region of Oklahoma and Iowa, and 230 milliseconds when my user was writing from London to Oklahoma, Iowa. I'll now test Azure Cosmos DB. What I have here is a multi-region setup. Azure doesn't support multi-writes for Postgres. That's only available for NoSQL offerings. But I have two regions, one essentially primary region with read and write capabilities, and one read replica region. I'll be testing what the user experiences when they're on both sides of the pond. And what we're seeing here is very similar to what we saw with the AWS Aurora setup. If you want a global database and read replicas around the world, this is the kind of setup you'll be going for. In my setup, I have UK South, which is London, as a read-write region, and US East, which is in Virginia, as an async read replica. I'm not going to spin these up again because it took over an hour to configure both of the databases. First, I'll deploy to London. I'll spin my application up. I'll deploy my secrets. And I'll deploy the app. This takes ages with Fly, so I'll speed this up for you. I will suffer though. I'll come over to Fly so that we can start to see monitoring when it's available for the app. Here we go. That's nearly done, so I'll switch over to my browser. And once the app has launched, it will be pulled, the Firecracker VM will launch, and we'll start to see read and write latencies. Okay, and here we go. So read and write latencies from London to the Azure London Cosmos DB region are really low. We're seeing around 1 to 2 milliseconds of read latency and around 3 to 3.5 milliseconds for write latency. Really positive so far. I'll tear down that application. And with that down, I'll switch over to the States. I'll launch my app again, but this time I'll set it to the States. I'll deploy my secrets and I'll deploy the app. Note that the write URL I'm using is the same one I was using before. That's the only way I'll be able to write to the database. But this time the read URL is reading from the States, from the async replica. To recap, this isn't the only database with asynchronous replication. AWS Aurora also uses asynchronous replication. I was seeing around 400 milliseconds of read latency where I was writing to the London database and waiting for the async replica. In the application, every second I'll make a write and then I'll make a read. The read will wait for the data to become available in the replica before the next write is allowed to occur. I'll write to the database. I'll then make a read. I'll enter a loop where I'll try to find the data that I just wrote into the database. If I don't find it, I'll sleep for a short period of time, 50 milliseconds, and then I'll try again. And I'll keep on sleeping like that until the data is available in the read replica. This time I'd expect read latencies to be slower as we're reading from an asynchronous replica. The application is deployed, and at the moment we're not seeing any read-write latencies, and this concerns me as I suspect that I've made the write and now I'm just waiting for the read, but we'll know in a minute. Okay, so we're seeing 225 milliseconds for write latency and 51 seconds for read on one of the workers and 40 seconds of read latency on the other. I'll let that settle in for a minute. That does seem to be the pattern. The write latencies have come down by quite a margin, but they're still around the 180 millisecond mark. And the read latencies are really, really high. So 55 seconds, we've left the millisecond mark, now we're into the seconds, and 50 seconds for the other worker. I'll let this run a little longer just in case this is out of the ordinary. No, it's settled in at around the 50-second mark. The write latencies come down again, but not by much. Okay, so I'll tear that infrastructure down one last time. To summarize, that was quite surprising to me. I was impressed by the low latency for local writes, but the read latencies against read replicas really surprised me. And there's a rule that says that if your entire round trip time, including database and any APIs in between, takes longer than 100 milliseconds, it's perceptible to users and therefore starts to become annoying. At the 50 to 60 second mark, this puts read replicas in a Cosmos DB infrastructure out of the equation for real-time transactional data. Users in different localities simply aren't going to wait for the data to become available. And how do you gauge consistency in a database where read replica data isn't available for up to or beyond a minute after writing? Once the data is available in the read replica, it might be very, very stale from the primary data source. If you want to use Cosmos DB for your globally distributed workloads, you might want to consider deploying different read-write regions depending on the locality of your users, just so that everyone can enjoy low latency reads and writes. But then you're in the world of disparate siloed databases where you have to manually stitch together the data in order to gain a holistic view as to the characteristics of your global database. This is quite a contrast to CockroachDB, where you can deploy a globally distributed database while having users enjoy low read and write latencies regardless of where they are.